Hi everyone, I'm Raghav, and in this video we will discuss the problems from the Leetcode Contest 383. And this is the first problem of the contest, ant on the boundary. In this problem, we have been told that there is an ant on a boundary. It sometimes goes to the left side and sometimes goes to the right. You are given an array of non-zero integers nums. The ant starts reading nums from the first element to the end, and at each step it moves according to the value of the current element. If the given value is less than 0, then it moves to the left side. Otherwise, it moves to the right side by that amount. And we have to tell the number of times the ant returns to the boundary. And then they have clarified something that uh, the space on the left and right side is infinite. So it will not happen that you cannot go a lot on the right or left side. Like just some simple clarification. Uh, Wait a second. Please move on. Yeah. So it is like there is some infinite space, and ant is right now at some balcony or whatever word. Sorry, boundary. It is at boundary, whatever word we use, and you will be given an array. Let us say if the array says 7 here, it means that the ant will go 7 units on the right. If it says -5, it means the ant will now come back to -5 units, so it will be at 2 units right from the boundary. Let's say if it has -2 once again, now, then in that case, it will come up left once again, 2 units, and it will become to the unit. It will reach to the boundary that is at the position 0. So what we can do is we can just say let us take the starting position of the ant, which is at the boundary, be position 0, and then we will traverse over this array from left to right. In case if there is a positive number, we will just say that go to the right side. So in that case, pause, like just increment position by num psi. In case if the number is negative, then we are going on the left side. So pose minus equal to, and how much, by how much amount are we going? If the amount was -7, we are going to the left by 7 amount. So maybe either you can say it as pose minus equal to minus nums, है ना? Because nums I is negative. If the nums I is -7, then you are going on the left by 7 amount. So either you can say it like this, as in the way problem has told us, or in simple words, you can see that in both the cases, the only thing you're doing is pose plus equal to num psi. Because if the number is negative, like saying this thing is equivalent to adding a plus thing, है ना? Subtracting a negative thing is equivalent to adding that positive thing. So at every step, what we are doing is only this thing. We are just adding num psi. In case if num psi is negative, then it will automatically go to the left side. Otherwise, it will go to the right side. And then we can just check that, hey, if position is equal to 0 now, in that case, just increment answer by 1. Answer will store the number of times you have been at the boundary. You can just declare int answer somewhere initially, and we will be doing these two things for each and every I. I hope that it makes sense that what we are doing and why we are doing. So here is my code for this problem. Or before that, we can just have the dry run for these two example test cases. We have the first example as 2, 3, -5. So in this case, ant will initially be at the position 0. When it got 2, it will move on to the 2 right steps. It will move to this place. Now it saw another 3. So it will move on 3 steps on the right. That is, it will reach 5 now because it was initially at 2 and uh, it moved towards the right side by amount 3 or 3 units. And then it saw -5. So it will move on left side by 5 amounts, or 5 steps or 5 units, whatever you say. And now the ant would be at position 0, which is the boundary. So the answer from 0, it should become 1. And the position variable would have initially been 0. After coming to 2, it would become 2. After coming to 3, it would become 5. And after reading this -5, it will become 0. Right. So our Dragon, like the logic we have figured out is also working here. We have verified that thing as well. And similarly, you can just check out this example. Here, the positions are 3. Sorry, the numbers are 3, 2, -3, -4. So first of all, the ant will move from 0 to 3. After that, it will move 2 steps on the right, that is, it will reach 5. Then it will move 3 steps on the left, so it will reach this position 2. Like it is moving like this. Then it will move 4 steps on the left. So from 2 minus 4 steps, or like 4 steps on the left, will take that ant to -2 position. So you see that the ant never reached the sorry, boundary once again. Huh? So the count of the number of times ant reached boundary here would just remain to be 0. The code is pretty simple. You will just go on, like you will just traverse this array, the given array, and keep track of the position. And in case if the position becomes 0, that is the ant reached the boundary once again, then increment answer by 1. That's it. So the time complexity here for this problem will become um, these things are in just big of one time complexity. This is a for loop, so for loop will run n times, inside which we have been doing big of n operations. So overall, this for loop will have a time complexity of big of n, and this is big of n. So the final time complexity for this problem will be big O of n. Okay, so I hope that this problem makes sense. Let's move on to the next problem. The second problem is minimum time to revert word to initial state 1. In this problem, we have been given a string word and an integer k. At every second, we will perform these two operations. Remove the first k characters from the word, like remove the first k characters from the word, and add any k characters to the end of the word. And they have just clarified that the characters which you remove from the start, like you don't have to necessarily um, add only those characters. You can add any characters of your choice. It should be just, they should be just k characters. Now it's up to you which characters you want to add. And we want to find the minimum time which is greater than 0 required for the word to revert to its initial state. So what does it mean? You have been given some string. Let's say the string is ABC, sorry, ABAC, ABA, ABAC, ABA. Like this is the string here. And the value of k is 3. So what it says is, at every second, you will have to erase first k elements. So after erasing the first k elements, the string will be CABA, and then you will add 3 characters of your choice. It does not really need to be the same characters which you removed. You can add up anything. Like if I want, I can add ZSH, like whatever I want. Whatever I want. Okay. Now the problem asks that this thing will happen in 1 second, and after how many seconds greater than 0. So you cannot talk about the initial state. You cannot say something like I didn't do anything, and you have to do something basically. Sorry. Yeah. So what you have to do is you have to perform these operations every second. Let's say after 1 extra second, something else happened. And after some point, the string should actually look up in the exact same way this one looks like. So ABAC, ABA. After performing some operations, the string should again become in this way. And you have to tell what is the minimum possible time you would require to reach from here till here. Like, let us see this in the example. ABAC, okay, this exact same thing. AB, AC, ABA. What you could have done is, at first you will have to delete the first three characters. So A, B, and A will be erased. And you will have to add on three extra characters. Let us say that I added three extra characters. Now what will I add? I will see it later on. Now after that, this new string which I got, I want it to be just like the given string. Though in this case, we can see that since these four characters, the first four characters of the new string, which are like fixed, I can have only CAB as the first four characters. I have control over these characters, but not over these. So these characters are not really equal to the first four characters of the given string. In that case, I can clearly say that right now, after 1 second, it is not possible to convert, like to choose some characters for these three positions and have it equal to the first, the string. So obviously, I will have to perform the same operations one more time for one more second. So I will delete first three characters and I will add first three, like three extra characters of my own choice, whatever characters I put up here. Since I don't really know about what characters should I put up right now, I'm assuming that I did put up something and I'm denoting them with a dash right now, or an underscore. Now see once again, is it possible to put up some values in these six positions so that the final string you will have of seven characters would be equal to this one? Pause the video and try to think about it. So I hope you tried this out and you realize that if I put up something like BAC ABA here, then this string will become the given string, equal to the given string, right? How will you be able to verify? Like, how will you check what characters to put up, or how you can make the string equal? See, if you want these two strings to be equal, the very basic thing is, let me change the pen. Yeah. The obvious part is that the last character would be equal to the last character. The last second character should be equal to the last second character here. The last third character should be equal. Similarly for the fourth, last fifth, last sixth. Because if you don't put up these characters, you obviously cannot make this new string equal to the given string. So for these characters, you can actually, like, it's up to you which characters you can put. So you know it for sure that for the last characters of this given string, I can definitely make it equal. If I have erased, if I have erased d number of characters so far, then I can make up the last d characters equal to the given string, because these characters are in my hand, which character I want to put up here, right? But the first n minus d characters, if I erase d characters, then the first n minus d, basically the remaining prefix, the remaining string, should be equal to this string, है ना? These correct, after once I have deleted some characters from the given string, I'm having some characters which are fixed. I don't really have any control over them. So it should be equal to this thing. If these two things are equal, in that case, I can say that after, like, 1 second and one more second, 2 seconds have passed so far. I can say that after 2 seconds, I can make I can make the two strings equal by putting up something here. Right. I hope that this thing makes sense. I actually over explained it. Even this much explanation was not really required for this part, I guess. So the approach we have figured out so far is, I would be given some string. Let us say we take up the same string once again, ABACABA, and you will have like after every second, let's say 1 second has passed, I will erase the first three elements from the string. Now what I want is the last four characters which are remaining in the string, this CABA thing, and then there will be three extra characters which I can always manage. So my goal right now is the these four characters should be equal to the first four characters of the given string. Or in simple words, I want to check if I want to check if it is possible, key right now, let's say that the given string length was 7 and after k was equal to 3 here. So if I seconds have passed, here I is 1, in that case, I would have erased k into I number of first starting characters. So now what I want is the suffix which does not include the first k into I elements, that is the suffix of length n minus k into I. The suffix of this length should be equal to suffix of this length should be equal to the prefix of the exact same length, obviously, the prefix of n minus k into I length, right? Can I say this thing? Like just making the thing generic, look generic. What I want is, I want to check for this I when I is equal to 1 that whether the suffix of since I have removed these elements have been removed. So the suffix of the remaining length, is it equal to that many characters of the starting of the string, that is the prefix of that length or not? Now, if you look at that if you look at the constraints here, the word length is very small. It is just 50. So even something like n cube or n raised to the power 4 can pass here. We don't really have any strict constraints. So if you are able to think of this much logic, you can clearly notice that for every I, for every I can just run a for loop to check if the first, let me use a word rem for this, or remaining. Let me use the word remaining for this right now. So the first remaining, like prefix first remaining characters, or you can say the correct prefix of first remaining characters is equal to last remaining characters. There, this remaining word is actually talking about this number, or if you want, you can just say it to be n minus k into I. So you just have to check out this thing. So you can just run up a for loop for this, right? The constraints are very small. You can just go on with absolute brute force. Just imagine if you're talking about some I. Let's say for right now, you're talking about I equal to 1, or maybe I equal to 2 now. Then in that case, from the string of length n, the starting k into I characters would have been deleted. So there will be some characters remaining. Let me call k into I as d, because I used the word d equal to k into I during in the code of mine. So in that case, I can here say that I have n minus d characters remaining. I want the suffix of this to be equal to the prefix of length n minus d. So the prefix will start from 0, and um, the last character of this prefix of length n minus d would be n minus d minus 1. You can just verify this thing. It is a basic thing. I'm not really explaining it right now. And the last character of the suffix of length n minus 1d, n minus d would be n minus 1, right? It would be the last character. And the first character of the suffix would be, like, this is something you can verify, that what if d was equal to 1, then the first character should have been n minus 1. So d, like n minus d should be there. The first character should be n minus d. Um, Now, how I got it is not so hard. It's something not so hard. The way I just told right now is, you could just do some um, put up some values here to get the value. So let's say if d was equal to 2, then you want the last two characters of the string, which are having indices n minus 2 and n minus 1. So for getting a suffix of length n minus d, the first character is coming out to be n minus 2. You can still Just verify it for d equal to 3, d equal to 4, and so on. And you will realize that n minus d is going to be the first character of the suffix. So you can just run up a for loop, compare this guy with this guy, compare the n minus d plus 1 guy with guy at index 1, and so on till you compare n minus 1 with n minus d minus 1. And that's it. If at any place you figure out that some character is not matching, if at any place you realize that the character is not matching, in that case the answer would be um, like it would not be the case. In that case you will go for the next second. You will say that I will apply some more operations, I will check out for the next second. But for some I, if it is matching, if all the characters of the string are matching, in that case you will say ki you have actually found both of the strings to be equal. Basically, the suffix and the prefix are equal. For the next characters which you have to put up after these characters, you can just put up them to be equal to this guy, so that you can just keep it matching. So here you will just return I, where I refers to the number of seconds which has passed, including the current second. So I hope that at the very least you have understood how you can calculate it for a particular I, or how you can check the answer for a particular I. And I believe you should have got the way we approach to get it as well. Now the question is, till which second should I check? Like if you try to see uh, when will the loop terminate, let's just try to see when will the loop terminate. Just imagine if k is equal to 3. First of all, the first three characters would be removed. Then the next three characters will be removed. Then the next three characters will be removed. Then if there are less than or equal to three characters left at the end, they would also be removed, these characters. And my string would actually just become up a string of all the characters which have been put up by me. Let's see if there is an example here as well for this. 1, 2, 3, 4, 5. Yeah. A, B, C. Let us take this example. A, B, C, B, A, B, C, B, A, B, C, and D. Right. So if this is the given string, here you can see, first of all, in the I equal to 1 second, you will remove these first two characters. So your string would be CB, AB, CD, and two arbitrary characters. This prefix, these two strings are not equal right now. So after this, the new string you will have is gonna be the first two characters would also be removed. You will have A, B, C, D, and then four arbitrary characters. Again, this does not match this. So you will have to go on with an operation once again. So you will come up with CD and then six uh, blanks, basically six arbitrary characters. It is still not matching. Then like CD is not still not matching AB. So you will just erase these two as well. And now you will have a string of all arbitrary characters. So obviously, if you are having all the arbitrary characters at this point, you could just say, yeah, I will put up all of these equal to the given characters and thus my string will match. So at some point of time, or to be precise, n by k rounded up. After this many times, the complete string would be erased and you will have only arbitrary characters left. So the answer would never be more than this. In this many moves, you can always make the string come up to the initial state. So the way I did code it up is I just ran up a for loop from of I from 1 to I is less than equal to n. And for every I calculated the number of characters which would be removed. If I see that D is greater than or equal to this n, it means that uh, after this current second or at this current second, the whole string, the given string like the string which was being given to me, all of those characters would have already been removed. I would have some arbitrary string with me. So I can just return I, because now since this whole string is arbitrary, I can just make it equal to the given characters. And otherwise, in case if d is less than n, then I will just check up for um, I will just compare the suffix of length n minus d with prefix of length n minus d. I will just compare both of these things. If both of them are equal, then I will just return I. Otherwise, I will check for an next I. And eventually, I will have my answer at like inside the for loop only. Let me show you that in code. So here I first of all just declared some variables. After that, I came here. I did ran up a loop of I equal to 1 to I is less than equal to n, because uh, we have to tell the minimum time greater than 0. So you will start with the time greater than 0, that is 1. This I is telling about the number of seconds which has passed. So when 1 second would have passed, I would have erased I into k number of characters, which I'm storing into d because I don't want to write up I into k again and again. And now, like one thing you can do here is just write up this condition that if d is less than greater than equal to n, then return I. Earlier I had written this thing, but later on I realized that even if I don't write this thing, um, the answer will still be the same, because if d is greater than equal to n, then j would be initialized with d and it will never go inside the loop. So it will just come up here, though you can just declare it for simplicity. So what we are doing here is, after checking up the number of characters which we have erased, if it is less than n, then we are coming up here. This is the starting position of the suffix, if you remember. Uh, like since we have, oh, sorry, I think that um, I think that I made a mistake here. We will see it later on. For now, let us think in a different way. Since we have erased first d characters, so what do you think? The index of the first character would be 0 and the index of the dth character would be d minus 1. So the suffix with which you are left up, the first character of that suffix should turn out to be d, right? The index of the first character should be d. Probably I made a mistake here. Um, I made a mistake here. Sorry for that. It should be yeah, this thing makes sense. It should be d only. It should not be n minus d. Sorry for that. I made one mistake there. And let us see this for the prefix as well. The first character of the prefix with which I want to compare this suffix would be 0. And the since I know that the length of the prefix is n minus d, so the last character of the prefix, if I'm talking about this prefix, would be n minus d minus 1. That is the n minus dth character. So I will just compare both of these things. For that, I'm just thinking j here is equal to d. So the first character of the suffix is word of j, and the first character of the prefix is nothing but this. Just subtract d from the index of the character of suffix. If you are not really comfortable with word of j and word of j minus d, then you can simply write with two pointers. Probably it should be clear. I'm just comparing word j with word j minus d because these are the first two characters of the prefix, and later on j would increment for every character. Then we are having OK equal to false, just in case if we find any character to be unequal, then we break. And in case if we see that none of the characters mismatched, in that case OK will remain true. Then we will just print, just return I, and that's it for this problem. So I did over explain this problem a little bit, and the reason behind this is because in the last problem, this is nothing but a follow problem of the second problem. So I think that over explaining here makes sense, so that I will not have to explain that much in the last problem. So I hope that this problem is clear. Let us discuss the time complexity also. These two things are having a time complexity of just big O of 1. These are constant operations. Then there is a loop which like it looks like it will have an iteration. It looks like it will have an iteration, but actually this loop will break when d will become greater than n. So if you try to find out the number of iterations, maximum possible iterations for this loop, it would be n plus k minus 1 by k. Basically, the Ceil division of n by k, that many iterations, because it will have only that many iterations till which I into k is smaller than n. Now, inside which we are having this for loop, which will have n minus d iterations in general, because we are comparing two strings of n minus d length, where this d can vary, and these things are of constant time complexity. This is also constant time complexity. This is also constant. So for every iteration, I'm having just constant time complexity, and the number of iterations would be in order of, like, this is in order of big O of n, and this is in order of big O of n by k, and this is in order of big O of n. So the overall time complexity would be somewhere around big O of n square by k. The overall time complexity here should be big O of n into n by k. Something like this, which is pretty good enough. We have very small constraint, so it will easily pass. So let's move on to the next problem. The third problem is find the grid of region average. You are being given 0 indexed m into n grid image, which represents the grayscale image, where image ij represents a pixel with intensity in the range from 0 to 255. And you are also being given a non-negative integer threshold. Okay, so first thing is, the problem statement might look a little bit complicated, but what you need to remember from this problem statement is that you are being given a matrix of n into m size. Wait a second. Yeah, you are being given a matrix of size n into m, and every element of the matrix would be in the range from 0 to 25 to 55. That's it, which you need to remember. Then we have been told that two pixels a and b are said to be adjacent if the um, absolute difference of their row plus the absolute difference of their column is 1. So this is just some mathematical way of representing the adjacent elements. We already know what will be the adjacent elements. Like for this 10, the adjacent element will be 9, this 7, this 10, and this 13, right? For this 10 here, the adjacent elements will be the elements which share a common site. And they have defined a region is a 3 into 3 subgrid, like this one, a 3 into 3 subgrid, where absolute difference in intensity between any two adjacent pixels is less than or equal to threshold. So for all the elements, let me write it in one note. 5, 6, 7, 5, 6, 7, 10, 8, 9, 10, 10, 8, 9, 10, 10, and then 11, 12, 13, 10. 11, 12, 13, 10. Right. This is the given grid or given matrix. It says that it says that a subgrid, or not a subgrid, but a region is a subgrid, basically a grid in itself of size 3 by 3. Like this one is a subgrid of size 3 by 3, having 3 rows and 3 columns, where for every element, if you talk about this element, it has these 4 adjacent elements. So its absolute difference with all of these adjacent elements is actually less than or equal to some given integer threshold. Now, what you will have to do is you will have to compare for this integer 9, you will have to compare its absolute difference for these 4 adjacent elements, and check if it is greater than or equal to or less than equal to threshold or not. So absolute of 9, and if you compare the 6, would be 3. And the given threshold, the given threshold to us in this problem here is 3. The given threshold is 3. So you will now just have to check for every character, like for this character in the subgrid, whether its absolute difference, whether its neighbors is less than equal to 3 or not. It is equal to 3 for this case and less than equal to 3 for this case. So it is fine. For this character, it has 3 neighbors. With all of them, the threshold is less, like the absolute difference is less than equal to threshold. For this character, what do you think? What will be the neighbors? Will it have these 3 neighbors, adjacent elements? So yeah, for the complete string, it has these 3 neighbors. But right now we are talking about the region. In the region, you will only consider its neighbors as these 2 for the subgrid, right? Have to talk about the region. They have actually said a region is a 3 by 3 subgrid where absolute difference in intensity between any two adjacent pixels, like they are actually talking about adjacent pixels within this subgrid or within this region. So for 7, you will compare it with these two elements. The threshold is less than equal to 3 right now. For this element, you will compare it with these 3. The threshold is less than equal to 3 for, sorry, the absolute difference is less than equal to 3 for all of these adjacent elements for 8. Similarly for 9, for 10, for 11, for 12, for 13, you can check it out. With all the adjacent elements they have within the subgrid, the absolute difference is less than equal to 3. So you can say that this one is a region. This one is a region. We just did a dry run on how you can check out whether a given subgrid, for a subgrid, whether it is a region or not. The next thing is all the pixels in the region belong to that region. Yeah, all the pixels which are in that region belong to that region. Note that a pixel can belong to multiple regions. Here is an example in the given problem statement. Like, sorry, in the given problem, if you look at the 7 or 6, these are coming up in 2 regions, right? These 6 elements are actually coming up in 2 regions. So an element can belong to multiple regions. You need to calculate a zero indexed m into n grid result, where result I is the average of the region image to which image ig belongs. So result ij is equal to the average of I think it's asking for average, right? Yeah, the average intensity. um, let's say that this region did not exist. There was only this one region. Let's forget about all these nodes. Sorry, not nodes, but forget about everything here, the whole row, whole column. In that case, what we will do is for every cell, we will say, tell me about the regions to which it belongs. Here in this case, all of these belongs to only one region. So for this region, you will calculate the average of all of these elements. The average of all of these elements will turn out to be 5 plus 6 plus 7, which is 18, plus 8, 26, plus 9, 35, 45, and then 56, 68, and then 81. है There are 9 elements, and the total of them came out to be 81. When you divide it by 9, you will get the average, and the average will turn out to be 9. So what you will say is, for every element, its result, for every cell, its result would be equal to 9. For this one, the result of this cell would be 9, the result of this cell will be 9, the result of this cell will be 9, and so on. This is what the problem says for result. Now they have clarified one more thing. In case if the, just imagine if this, instead of this 5 there was a 6, then the total would have turned out to be 82, which when you divide with 9, it turns out to be 9 point something. So you will just round it down to 9. You will just leave everything after the point. This is what this line is saying. Belongs um, rounded down to the nearest integer. Then the next thing they have said is, if for some ij, if for some cell ij, if this belongs to multiple regions, like the 6 belongs to multiple regions, the 7 belongs to multiple regions, then result ij will be the average of result, sorry, average of the rounded down average intensities of the region. Looks complicated, looks a little complex. Okay, let us see this again here. If there are a lot of cells in the given problem, let us say that right now I'm not giving any values here. Just imagine that there is a region here. Sorry, this is, it should be 3 by 3. Yeah. So let us say that this is a region having these 9 elements, and there is another region like this one, which also has 9 elements. There are only 2 regions. So for the elements which belong to exactly one region, that is these elements, what we have to do is very simple. We already know that these elements will have the average of the region to which it belongs. So if the average of all these 9 elements turns out to be maybe 16, then the result of all of these elements will also turn out to be 16, 16, 16, 16, and 16. Similarly, for these elements, okay, let me write up the region, the thing as well, 16, 16, 16, 16, 16. Now, for this region, if the average of this turns out to be maybe 12, in that case, it is again simple. For the elements which just belong to one region, their average, like their result would be nothing but the average, as the problem asked, told us earlier. Sorry, it would be 12 here, no? The average is 12, 12, 12, 12, 12, 12. And for now, for these now for these elements which belong to multiple regions, the thing is, if this is the row 2 and column 3, or maybe column 2 row 1 in zero based indexing. So result of 1 2 will be the average of region 1, take average of region 2, and act and just take the average of both of these things. So it will have the average of the averages of all the regions it has been a part of. Like this is a part of 2 regions, one region having an average of 16 and one region having an average of 12. So you will have the average of 12 and 16, average of both of these things being put up here, which is 14. Similarly, for this one, it also belongs to only 2 regions, only 2 regions, only 2 regions. Hai na? These values will be 14. So I hope that the problem is completely clear. And why is this happening? What is happening? Okay, I just forget about it. So what we have to do is we have to find the result of every cell. So one thing which you would like to see first is, what are the constraints on the problem? The constraints are not too huge, right? The constraints are not too huge. The matrix is not so big. And the other thing which you would notice here is yeah. Okay. So the thing which you should notice here is, since the subgrid would be of size only 3 into 3, so there are not too many subgrids. Like for every cell can be the first cell of at most one subgrid. Let me show this thing. This is a very crucial observation which you should always look up for. There, you can see this kind of observation in a lot of problems, that this cell can be the first element or first cell of only one subgrid. There is exactly one subgrid. Similarly, for this cell, there can be only one subgrid for which it can be the first element. For this element as well, there can only be one subgrid. So since there are n into m elements total, there will be at most this many subgrids of size 3 into 3, though there will be many elements for which there is no subgrid, like this element cannot be a part of the first, cannot be the first element of a subgrid, since there are not that many rows after this. There are only 2 rows if this is the first element, whereas you need 3 rows. So you got the idea that there will be less than this many subgrids. If you want the exact amount, it would be there are n minus 2 rows for which the first element, like which can be the first element for a subgrid, है ना? For any element in the sorry, for any element in the last two subgrids, for any element in the last 2 rows, sorry, last 2 columns, these cannot be the first element of the subgrid, because if this is the first element of the subgrid, there has to be 2 more columns which are not available, है ना? Similarly, for the last 2 rows, so you will see that there are only n minus 2 rows and m minus 2 columns for which the first element can be the cells can be a part of the first can be the first element of a subgrid. So there are only this many subgrids, right? Hopefully you would have got this idea that there are only this many subgrids, and every subgrid is of size only 3 into 3. So what if I say that there are only limited number of subgrids? So for every subgrid, go for every subgrid, iterate over this 3 into 3 subgrid of that, and verify if this is a subgrid or not. If this, sorry, if this is a region or not. If this is a region or not. We know that this is a subgrid, but we want to verify if this is a region or not. Verifying if it is a region or not is a very simple thing. Let me take an example here. There are some adjacent nodes. You just, like the lines which I'm drawing, you just want to have comparisons between all of these elements, है ना? So what you can do is, for every element, you can just say if there is an element on the top or on the left, just compare it, compare the absolute difference of this element with the element on the upside or on the left, and just check if it is less than equal to threshold or not. If it is greater than threshold, then mark it somewhere. Similarly, for this element, just check out on the top and on the left. For this element, check on the top and then on the left. And once you do this thing for every element, in that case, you will just get all of these comparisons being done which you wanted to cover, right? So verifying whether the given subgrid is a region or not is a simple thing. After that, in case if it is a subgrid, then you eventually want to find out, like you eventually want to do something like store the average of the region into all of the cells, right? Just imagine that you found that this subgrid is a region. Then what you want to do is, for every cell, you just want to mark down that, hey, all of you are a part of a region with whatever the average of this region is, right? And at the end of the day, if for every cell, once you would know about the sum of averages, you can just divide it by the sum of the number of regions to which it belongs. Like, let me show you a dry run here. Say that for this node, you had stored that this is a part of a region of average 16, and it comes up in only one region. Or maybe you could have just stored that this specific cell is a part of one region, 16. This specific element is a part, this cell is a part of one region with average 16. Similarly, for other cells, for this cell, you could have stored that this is a part of two regions, 16 and 12. And at the end, when you would have found out all the regions and you would have marked for all the cells to the averages of all the regions to which they belong, then you can just take up the average of all of these elements. Hai na? 16 and the average of 16 and 12 is nothing but the sum of them divided by the number of elements. So if there had been, if this was a part of, let's say, 5 regions with average 8, 9, 10, 11, 12. So one thing you can do is just store the averages of all the regions to which this element belonged. Or the other thing is, at the end, what you would do is nothing but 8 plus 9 plus 10 plus 11 plus 12 by 5, right? You would just do this thing. So what you can do is just for every element, keep track of the sum of the averages of all the regions to which it belongs and the number of regions to which it belongs. So that you would have to store only two variables uh, for every cell of the given matrix instead of storing the number of regions. Though you can store this thing as well, since it would not be greater than 9. Any element cannot be a part of more than 9 regions. This is something you can verify, as there are only 9 positions for any cell to be a part. Like for any region, it can be coming up at only 9 places. So there will not be a possibility of more than 9 regions for any element. Okay, so I believe you got this thing, that for every element, you can either store this thing or just store the sum of the regions and the number of regions to which it belongs. I did store this thing, but you can store this as well. So what we will do is for every element, for every cell, we will just store, like verify whether it is a region or not. After that, we will store this information. In case if it is not a region, then continue. If not, then continue, like go on for some new subgroup, then just continue for some next subgroup. Otherwise, store the like whatever information you want to store, like either this information or this information, and whichever information you want to store. So right now I'm just saying store the info. This is what you will do. And once you have stored the information, you can just move on to the next subgroup. Now, so once you would be done with all the subgroups, now for every element you would know the sum of sub, like you will have any one of these informations. So you will just go to every element once you're done with every subgroup. Now you will go for every element, or every cell actually, every cell of the given matrix, and you will calculate the um, result, the result of ij. How will you calculate? We will calculate it with the help of the information which we stored. So in my case, I did store the information as sum ij, which will tell me about the sum of averages of the regions to which this region, sorry, not regions, to the regions this cell belongs to. And I stored cntij, which will just tell me the number of regions to which it belongs, the number of regions it belongs to. That's what I did store. And at the end, the result I would be, just imagine if count comes out to be 0. It has been mentioned in the problem that if image ij does not belong to any region, then result ij is equal to image ij. So in case if it does not belong to any region, the count ij would be 0. So you can just say that result ij would be nothing but image ij, right? We'll just say something like this. And in the other case, in case if the count is greater than 0, then you can simply say ki result ij is nothing but the average of all the regions to which it belongs, and that through being rounded down. So it is nothing but sum of ij. Sum of ij will tell me the sum of all the averages of all the regions to which it belongs, and divided by cntij, and that's how I can find the average. So that's it. I will do this for every cell, and then I will return my result. I hope that this logic is clear. Let me show you in the implementation. You got some idea for the implementation also. So you can code it in your own way. For in my case, my implementation is a little long, though I think it can be made a little shorter, probably. What I have done is I did find the size, the number of rows, and the number of columns. And then I said, key, I will store two things for every cell: the sum of the averages of the regions to which it belongs and the count of the number of regions to which it belongs. And then there is a function which I declared. Like, you don't really need to declare a function. You can just write up this exact same thing instead of the function. By the way, for those who don't know about lambda functions, this is nothing but a simple function with name check region. Whenever I call this thing with two parameters like this, it would run exactly like a normal function. The only advantage it has over a normal function is that as I want to use the thing like image, this vector, or something like sum and count, I don't have to pass this in the parameters. I don't have to pass this thing in the parameters because these variables which I have declared here would be accessible in the complete block scope. So it is having only this advantage that it is coming up in the block scope of the function. So I can use up some things without actually passing them through parameters. So what we are doing is we are going on for all the starting positions, all the possible starting positions. This These two for loops are for going to every starting position, and then after that I'm just checking if the subgrid starting with like having I comma j as the first cell of the subgrid, whether it is a region or not. So for checking whether it is a region or not, I've created a function and I'm just calling it up. You can just feel free to write up all this content inside this as well. So here what I'm doing is I'm just going up for all the 9 elements, the 9 elements of the subgrid. I just check up the two things which we were about to check here, that I will compare every element with the element above and the element on the left, because I just want to compare these elements. If you want, you can just compare all the neighbors, all the 4 neighbors for every element also. It will just like you can do it in any way. It's up to you. I feel this is the simplest thing you can do. So it is just checking that, hey, if I is greater than rho, basically this is not the first row of the subgrid. In that case, just check out the element just above it. In case if the absolute difference is greater than threshold, then return false. So in the function, I'm actually returning true and false also, whether the subgrid is a region or not, though I'm not really using that information. So even if I don't pass true or false, it is still okay. So if it fails on any of these conditions, it will just come out of the function. Otherwise, I'm just keeping track of the total of all the elements in the subgrid as well. And then I'm just going to every element of the subgrid and I'm adding the average of the subgrid to the sum ij. Like for every cell of the subgrid, I'm adding the average of the subgrid to it, and increasing the count by 1, that this element is a part of one extra subgrid now, a region. Now once I'm done with this, then I'm going on for every element in the or every cell in the subgrid, and I'm sorry, in the given matrix, the complete matrix, and I'm just checking if the count is greater than 0, it means that it is a part of at least one region. Then the answer would be the average of all of the averages of the sub regions. Otherwise, it would be just nothing but image of I omega, image of ij, and then I'm just returning it. So I hope this is clear. Um, Probably it can be written up a little small, like in some a little smaller syntax, but I think that it is also good enough. You could have eliminated this something. You could have just stored things in result first and then divided it by count. Like there are some simple manipulations you could have done to make the code a little smaller. Okay, so now let's move on to the fourth problem. This is the fourth problem: minimum time to revert word to initial state. So I will be continuing this problem from the place where we ended in the first game. In the second problem, we will start from there on. I will directly start from the observations we made there. We notice that we have been given a string. If I seconds have passed, if I seconds have passed, what we wanted to do was we wanted to check, like we would have removed the first k into I elements. So we wanted to check whether the suffix of length n minus d, like where d was equal to k into I, if the suffix of this length is equal to the prefix of length n minus d or not. If this thing was coming out to be true, we could say that it is possible for us to make uh, the string come back to the initial state in I seconds. We got this conclusion in the second problem. I'm continuing from that part. So the way we did the problem earlier, we will just do the exact same way. The only difference in this problem and the next problem is in the constraints. In the second problem, the constraints are very, very small. And in the fourth problem, the constraints are decently large. So in this problem, in the second problem, what we had done is we had gone for every second. We had checked that what if I remove the first I into k elements. For every second from I equal to 1 till n, I'm just going there. If I'm saying that in case if d is greater than equal to n, it means I can just remove the complete string, and I will have all the characters being added arbitrarily. So all the arbitrary characters. By the way, I repeat that just in case if you're watching the fourth problem and you have not watched the second, then please just have a look at the second problem. You can watch it at 2x or just skip half of the part which you know. So once you would have watched it, this is just a revision that d was equal to the number of elements we have been removing from the start after I seconds, because in the given string we have been removing first key elements. First key elements would be removed first, then the next key elements in the next second would be removed, and some arbitrary characters would be put up at the end, which we can just decide what to put up here for our convenience. So what we were doing is for every second from 1 to n, we just wanted to check, we just wanted to check that, hey, if for the given string, some d characters would have already been deleted. So if the remaining n minus d characters, and then I have some d characters which are arbitrary for me, if these n minus 1 in if these n minus d characters are equal to the first n minus 1 n minus d characters of the given string, of the original string, let us say if these characters are equal, then for the next d characters, I can just put up the exact same values which are present here. And in that case, I can just uh, get the string to back to the initial state as the problem asks me to do in um, I seconds. In I seconds. Hana? So this thing looks cool, but the problem with the solution here was it was running in big of n square. It had one loop here and it had another loop here. So not big of n square, but it was n into n by k. In the worst case, when k is equal to 1, it will run like big of n square solution. This is not so cool. No. Okay, so we want to optimize it somehow. And this problem, like this optimization is actually something standard if you have already done it somewhere. If you have already studied about string hashing, That's it. That's the thing which we can apply here. Like what we can do is, we know that you will have to you will have to compare this string and this string to each these two strings, or basically two substrings of the given string. So if you use string hashing, just convert strings to some integers, the way of comparing strings would take only big O of one big O of one or big O of log n time complexity, depending upon the implementation. I think it should be big O of log n. And now, like it would probably take big O of n time complexity depending upon the way you have implemented it. So we will be able to do the thing which we were doing with a for loop in big O of n time complexity here, with just function with some string hash, like a function sub str, which will just tell us about the hash value for the prefix and the hash value for the suffix, and you can just match if the two hash values are equal or not. In case if the hash values turns out to be equal, um, then it means if the hash value of the prefix turns out to be hash value of the suffix, then there can be two things. One of them is that you are very unlucky. The two strings might not be equal, but they got the same hash. Or the other thing is they are equal. The chances of this happening is very low generally, especially when you use double hash for string hashing. Like right now, I'm just expecting you to know about string hashing, or you should know about Z algorithm. A lot of people have done this problem using Z algorithm also. Any one of them is fine. So the only optimization in this problem from the second problem, like we will do the exact same thing which we did in the second problem, except that this time for comparing two characters, sorry, comparing two strings, the prefix and the suffix, comparing these two substrings, we will use a function, like we will just use string hashing. So the way we do it is like this. We just hash the given string. We just first of all hash the given string. The string hash, like you can just copy anyone's template. You can copy anyone's template or maybe create your own template. Um, and it should have this thing. Mainly this is the important thing which should have the substring hash. Obviously it will have the other things like this one. Probably it will have all of these things if you are copying it from some good guy. So use a string hash template, hash the string. Then for every I from 1 to n, as we were going in the second problem, in case if like d elements would be deleted, if d is greater than or equal to n, in that case it is obviously the whole string has already erased and you will just return I. Otherwise we were comparing the string, the prefix and the suffix, but this time for comparing prefix and suffix we will use hash substr, hash substring hash, like this function substring hash, which will just find out the hash of this substring. This will give me the hash of the suffix. This will give me the hash of the prefix. Then I can just compare both of these. In case if the hash turns out to be the same, then we are returning I. Though it has a chance of the two strings being different but having the same hash, but the chance is very small, so you can take a chance like this one. And the control will never reach to this return zero thing. I've just written it because I've just written this line because if I don't write this line, then leet code will give me an error that, hey, you're not having a return statement in the function, so you have to return something. Similarly for this problem also, we were returning something because you need to have a return statement in some function with some return type. But the control will never reach here, even if k is equal to 1. Then for I equal to n, this I into k would be equal to n. So this line will always come at some point of time. Okay, so I hope that it is clear. I hope that all the four problems The explanation for all the four problems were good enough. And thank you for watching the video. Bye bye.